These are the this what you have here is the specimen that you'll be expecting in the coming exam. So here we have specimen A, land snail, B, toad, C, spider, D, crayfish, E, spiragira filament, F, mucor/rhizompus, G, granule seedling, a week old, H, maize seedling, a week old, I, microscope, J, slide, K, pigeon, L, agama lizard, M, rat, and N, tilapia. So let's just quickly run through this, and I want you to be patient enough to watch, and then because that will be I'm going to compare all these things, because if you look at this place, I'm going to compare it in the next video. If you look at this, you find out that all of them are coming from um, the same phylum we know as Chordata. These other ones. Why do we call them Chordata? Because they have backbones, including this other one we have here that happen to be far away from the others. So they have backbones. All of them they have backbones. Now let's quickly look at the snail. The snail is coming from a family that we know as what? Um, coming from is coming from a phylum that we know as Mollusca. So these ones, one thing they about them is that they have what we call they have a tentacles. They have tentacles. They have tentacles. So they have shells. They have foods. All those things help them to survive in their environment. The food help them to move. The tentacle helps them to, you know, the tentacle bears the eyes that they use in order to see, while um, to see the environment. So the next one we look at here is the toad. The toad. One thing about the toad is that is what is found in the is amphibian. It can live in the water, and it can also live in land. Live on land. It can also live on land. And in the body, one of the adaptations that help it to survive is that it has a webbing feet that help it to swim in the water. The body is always moist. This moist body help them to do what? To respire. Do you understand? It help them to exchange gases. That is one of the features they have, because they have three methods of respiration: by the skin, the lungs, and the mouth, the one we call the buccal. Do you understand? That's the three methods of respiration you can find in this one. So then another thing is that the body can camouflage. The body can camouflage, can change, in such a way to adapt to its environment to avoid predators. So in this other one, the spider and the crayfish, they happen to be coming from the same phylum, which we call oh, the arthropodia. Coming from what? The arthropodia. They are known to have exoskeleton made up of what? Chitin. Made up of chitin. They are also known to have jointed appendages. They have segmented bodies, and both of these, the crayfish and this one, their body, and the spider, their body is divided into two. That's the thorax and what? And the abdomen. Now, unlike what we have here, the spider is in land, lives in land, and then the crayfish is always found in the water. Is aquatic animal. So these are some of the comparisons that we're going to do in our next video that we're going to be watching here. And in this other one, we have the spirogyra, and then we have the mucor or rhizompus. these two also, they are known as lower wards plants, lower plants. The Spirogyra um, mode of nutrition is by what? Photosynthesis, because it has green chlorophylls. It has green chlorophyll, and it's also fermented. While this other one, the mucor, they are non-green plants. They are non-green plants, and then the mode of nutrition is saprophytic mode of nutrition. Saprophytic in the sense, in fact, saprophytic in the sense that they feed on dead organisms. They help in they encourage the composition of dead organisms. And um, the next thing, their reproduction is by what? This other one is by sexual conjugation. While in this mucor, they have asexual and sexual reproduction. And the asexual reproduction, in the asexual reproduction is by spore formation, spore formation, while the sexual mode of reproduction is the one we call the conjugation, just like the Spirogyra too. So in this other area, we have the groundnut specimen G, which is the groundnut seedling. This groundnut seedling is the kind of germination we have there is what we call the epigel germination. I repeat again, epigel germination. Epigel germination is commonly is characteristics of what? Diocotyledon plants. It's got characteristics of dicotyledon plants, and because the cotyledons are lifted above the ground, they are lifted above the ground, and the plant that exhibit this one, they normally have net venation. They have net venation, and then and when we come over to this other ends, coming to the maize, we find out that a maize seedling is a good example of what we call the um, is a good example of the kind of germination we call hypogear germination. In this germination, the the apicots grow higher than the hypocots. So in that case, it grows higher. And this characteristics, hypogear germination is common with what? Monocots, the type of plants that have parallel venation. That is very common to them. And then it's mainly the grass families, mainly the grass families. So now in this other area, you can see that these two, they also have something in common, which means they are what they talk about the germination. And this other one, I believe that what we're going to see here is that we are going to use this to really examine these two lower plants closely. We're going to use it to examine the lower plants closely. Now coming down here, like I said, we have the phylum we call the Kudata here, plus this other one. In this family, they are known to have vertebral bones. They are known to have vertebral bones. Now let's quickly look at this. The pigeon has enough. It has the features that make it unique um, in the in this phylum. It has feathers, feathers, and to the leg where it has scales. So some of them can fly, some are flightless. They have beak, which help them to to their pick grains, which they mainly depend on. So for these other ones, for let's continue with the specimen K. Specimen K, they have a uh, constant body temperature as the homothermic body temperature. That means the temperature remains unchanged even in the midst of when the temperature of the environment changes, their body does not change. Unlike what we have in the lizard there has a kind of cold-blooded which changes with the environment. Now, looking at these things, the one, two, three, they are what we call the kind of reproduction. We have the lay eggs, and we know it to be what oviparous. They know it to be oviparous. This other one, the rat, is also among the kudata. But this one, like them, this other one, the rat born produce his son and his own offspring alive. That is what we call the viv viviparous. That is what the kind of reproduction they exhibit in their own case. So having done all these things, in the next video we are going to be looking at some of the comparison. We're going to compare them to find out some similarities and differences they have. Thank you so much for this time.